This is a relay module meant to be used with Arduino Nano and other similar microcontrollers. You can see the input pins here. These are the input pins, Vin, ground and VCC. The pins can be seen better now. These are the 3 pins. I'll use these jumper wires. You can see that one end is a socket and the other end is a pin. I'll use these to connect the relay. You can see that the sockets have been connected to the terminals on the relay. They are the input terminals, and this is the other end which you can connect to a breadboard. Now you can see the connections. That is D13. Is that D13? That is the digital output from Arduino Nano has been connected to the Vin, I mean input. And the black terminal, the central one, has been connected to the ground of the Arduino. This is the ground. And the white one, which is the VCC, input to the relay to run the circuit of the relay, that has been connected to the 5 volt. This is a 5 volt terminal from Arduino Nano. Arduino Nano can give a 5 volt input to devices connected to the board. That is a maximum of output is possible is only 500 milliamperes. But of the 500 milliampere consumption of the Arduino board, 200 milliamperes will be used by the board itself. Maybe another 300 milliamperes is available for this relay. Usually relays take only about 70 milliamperes. So let us see. Now I have connected the power supply, that is a power bank, to the Arduino Nano. This is the power bank. And you can see, observe what is happening. The red LED on the relay is the power LED, which lights up continuously, showing that the relay module is energized. The green LED shows that relay is being switched. So the relay is being switched on and off intermittently. I am using a blinking LED sketch in the Arduino Nano. Usually it blinks for 1 second on and 1 second off. That is the principle of digital output. That is, on is 1 and off is 0. This is the digital pin 13, which is used for blinking LED. I have shown it earlier. And this green LED is the relay indicator, relay state indicator. When the relay is on, it lights up. That is because Arduino gives a 5 volt output in the digital pin in the on stage and 0 output in the off stage. This LED is being lit from a different input, that is the direct 5 volt input from Arduino. That is not being switched. That's why it is continuously on. I have edited the blinking LED sketch in Arduino Nano. That is an example sketch which is free, public domain sketch. Usually it has 1000 milliseconds on and 1000 milliseconds off. I have edited it and uploaded again so that it will be 5000 milliseconds on and 5000 milliseconds off. That's for easy recognition of on-off. Otherwise, this LED will be blinking very fast, once a second. And according to the blinking of that LED, you can know that switching occurs in this other side also. These are the other ports which can be used to control other devices. I have a motor here, water pump, which can be controlled. Anything can be switched on and off by that circuit. You can see 3 terminals here. The central terminal will be common, and one of the other 2 terminals will be either normally on or normally off position. That we will try out in another experiment. This is a 21 watt 12 volt bulb. It's actually an automobile bulb. It's an enlarged view, 4x view. Actual view will be lesser. I wanted to show you the ratings. This is the actual view. I have soldered wires to both terminals because I don't have a holder at the moment. Holder is usually in the automobile. This is a demo testing this bulb with a 12 volt battery, storage battery. I am testing the current drainage by that bulb, that is 1.54 amperes. This is the bulb, and you can see that multimeter is in the 10 ampere range. I have connected the bulb through the always on port. Central one is common, and this central one, that is common, and this is always on. The common port has been connected to the battery, and through the multimeter I am going to connect the battery. I have connected the battery, and the bulb is light, and we are reading 1.56 ampere. This is the 10 ampere port. So the current drawn from the battery is 1.56 ampere through the relay. So this is because the relay is in the always on position. Now I'll see what happens when the Arduino port is connected. Now I have connected through the Arduino. This is the Arduino, and this has been powered, and you can see that now the Arduino is switching the relay. You can see that now it is drawing 1.57 amperes, and now it is off. When the green LED lights up, the bulb is off. That is for 5 seconds. When the green LED goes off, the bulb is on. So it is the other way around. That is because of the connection in the relay. If I connect to the other terminal, the reverse will occur. So it depends on what you want to do. So I am driving the 12 volt 1.5 ampere circuit using the Arduino Nano. The program in the Arduino Nano keeps the bulb on for 5 seconds and then off for 5 seconds. The program can be changed by editing in the Arduino IDE software. I am checking the current drain in the digital pin of the Arduino Nano. Now it is 0 because the Arduino is in a switched off state, and now it is 3.5. So you can see that maximum current drawn from the Arduino pin, that is this pin, that is the digital pin, D13 pin, is only 3.5 milliampere. You can see that the range selected is in milliampere. I'll change it to 20 milliampere, so it will be more accurate. It is 0 when the output is off. When the output is off, the light will be on. That is the reverse connection. You can see that the light will be. So maximum current drawn from Arduino in the D13 pin is only 3.5 milliamperes. At the same time, we have seen that the current drawn by the bulb, this is the automotive bulb, is 1.5 ampere at 12 volt. This is a 12 volt battery. So we are using Arduino Nano to switch a higher voltage, higher amperage, 1.5 ampere 12 volt circuit using just 3.5 milliamperes from the D13 pin of the Arduino. This is the principle of this module, relay module. Relay module has an input of 5 volt at 3.5 milliamperes only. So that will not strain the circuits of the Arduino.